Good day everyone and welcome back to my virtual classroom. For our science discovery episode for today, we will be talking about the periodic table. So let's get started. The periodic table. In this video, we will explain how elements are organized in a periodic table, identify three broad classes of elements, and describe the information in a periodic table. How are the elements being organized? A few elements such as gold and copper have been known for thousands of years since ancient of times, yet only about 13 had been identified by the year 1700s. As more were discovered, chemists realized they needed a way to organize these elements. So the chemists used the properties of elements to sort them into groups. In 1829, J.W. Dobronier arranged these elements into triads. What does triad means? This is groups of three elements with similar properties. One element in each triad had properties intermediate of the other two elements. By the mid-1800s, about 70 elements were known to exist. Dmitry Mendeleev, a Russian chemist and teacher, arranged these elements in order of increasing atomic mass. Thus, this is the first periodic table. He left a few blanks for yet to be covered or undiscovered elements. When they were discovered, he had made good prediction, but there was a problem, such as copper and nickel, argon and potassium, tellurium and iodine. But there was a better arrangement, where Henry Moseley in 1913, a British physicist, arranged these elements according to increasing atomic number. And this is the new arrangement that we use today and see in our periodic table. So this is our current periodic table. The periodic law says that when elements are arranged in order of increasing atomic number, there is a periodic repetition of their physical and chemical properties. The horizontal rows here is what we call periods. As you would notice, there are 1, 2, 3, 4, 5, 6, 7 periods. The vertical column is what we call the group or the family. Similar physical and chemical properties are also shown in our groups. This is identified by number and letter: 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, and the B's. There are three classes of elements in the periodic table. So what are these three classes? The first class is what we call the metals. The second class is what we call the non-metals. And the last one is what we call the metalloids. The metals are electrical conductors. They have luster, they're ductile, and they're malleable. The non-metals, on the other hand, are generally brittle and non-lustrous, poor conductors of heat and electricity. Some non-metals are gases, such as oxygen, nitrogen, chlorine. Some are brittle solids, such as sulfur. One is a fuming dark red liquid, which is our bromine. Do you notice the heavy stair steps on the line? This stair steps that you see here? This stair steps is the border of your metalloids. The border line has two sides. The one on top are the non-metals, and the one below it to the left are your metals. So these stair steps that we would see here, these are properties that are intermediate between metals and non-metals, and these are our metalloids. Now, how are the numbers and the letters being interpreted in each box that we see in our periodic table. The number on top that you would see is our atomic number. The number on the side is the electrons in each energy level. This is what we call the electronic configuration. The letter capital N and small letter A is the element symbol. And of course, the element's name is written below it. And you would see a number below, which is mostly in decimal. It's 22.99. If it is in decimal, it is what we call the average atomic mass. Now let's go to how the groups are being done. The group 1A, which we see here on the first column, is what we call the alkali metals. These are forms a base or alkali when reacting with water. The group 2A, which is on the second column, is our alkaline earth metals. This also forms bases with water, but they do not dissolve well, hence they are called the earth metals. Group 7A, which is on the most end part before the 8A. So this is 1A, 2A, 3A, 4A, 5A, 6A, and then the blue column here is what we call the 7A. These are our halogens. Halogens means salt forming. The elements can be sorted into 4 different groupings based on their electron configurations as well. We have the noble gases, which is the last column or the last family, the representative elements, the transition metals, and the inner transition metals. Now let's take a closer look of these 4 groups. The noble gases are the elements in group A. So this is the 8A group. Previously, they are called the inert gases because they rarely take part in a reaction. They are very stable. That's why they don't react. Noble gases have an electron configuration that has the outer S and P sublevels completely full. The representative elements are in group 1A until 7A. This display a wide range of properties, thus they are a good representative. Some are metals or nonmetals or metalloids, some are solid, some are gases or liquids. Their outer S and P electron configurations are not filled. That is why they are reactive. So we have the last group, which is the transition metals. This is the B group, which is in the middlemost. The B columns of the periodic table is what we call the transition elements. A transition between the metal areas and the non-metal areas. That is why they are called transition metals. For example, they have gold, copper, and silver in your transition metals. There is also what we call the inner transition metal, which is our F sublevels. These are located just below the main body of the table. It is in 2 horizontal rows. They are formally called the rare earth elements, but this is not true because they are very abundant. And that's the end of our video for today for the periodic table. I hope that you have learned something new today, and for those that are new to my class, please don't forget to click that subscribe button and hit that notification bell for your attendance today. And as always, as Teacher Maria would say, please do live your life to the fullest, learn something new every day, and love one another as how our God loves us. See you next episode for our Science Discovery series. Bye!